Hello, my name is Danny Tapper and I am a sales manager here at Zupt. And today I'm going to be talking you through the V2 version of our 3D Recon system, which we use for subsea modeling and positioning. So the plan is to just give you a quick rundown of the system, of what's inside it, what it can produce, and then also what the applications are. And then I have a quick case study to show you. But most importantly, I want to highlight the exciting advancements that we have made recently, such as our ability to produce real-time dense reconstruction and our work towards automated ROV flight paths for asset inspections. So let's get into it. So here it is. Up here you can see the actual 3D Recon unit, and these are some of the high quality models that it can generate. So I just wanted to provide a bit of context at the start of the presentation to show you the system before we get into the technical details. So at its core, 3D Recon is a subsea imaging and positioning system that combines stereo cameras and a tactical grade inertial measurement unit. So we attach the system to an RV, which then takes passes around an asset while the cameras capture overlapping images from two different angles. And it's in that overlap that the data is captured. So at the same time, the IMU is providing pose estimation, telling the system the exact position and orientation relative to the structure between the frame grabs. This is different from traditional photogrammetry, which tries to estimate this movement from image content alone, which can introduce uncertainty. 3D Recon instead relies on its inertial sensor to provide true high-confidence pose solution in the 0.2 seconds between the frame grabs. This concept is built from the 20+ years of experience that Zupt has in incorporating our expertise of inertial navigation systems into subsea operations. So one of the major hardware updates in the V2 version is the 10 GB internal switch which we've added. So this allows multiple systems to piggyback off of each other by streaming through more data simultaneously. That means that there's more imagery at any one point in time, and it opens up opportunities like multi-camera pipeline inspections where that wider coverage and throughput are critical. Speaking on the applications, 3D Recon has many, but we like to break it down into these two main categories. So firstly, we have the high accuracy positioning applications, where it is used as precise measurement tool capable of completing full metrologies. It can deliver metrology level accuracy at 30 millimeters over 30 meter distance, which complements our core business quite nicely, working with inertial metrology. The second category is for all the model generation applications, like inspection and asset integrity monitoring. This is about giving the client a detailed, scaled 3D view of their assets so they can understand the condition in context and track the changes over time. In 2022, we took part in Chevron's Fast Digital Inspection campaign in Australia, surveying over 400 subsea structures in just 18 days, dock to dock. Of these, 200 structures were fully processed while still offshore, meaning the deliverables were available in a very fast manner. The key impact, though, was creating 3D models allowed Chevron's engineers to carry out their inspection directly on the model instead of relying solely on the live video feed. That shift cut around 40% of vessel days compared to the previous year's general visual inspection campaign. Because of the success in 2022, we were brought back for the 2024 campaign, and this time we completed 126 structures, 77 of which were repeats from 2022. This project showed how FDIs can change the deliverables from an inspection campaign or a traditional inspection campaign. A great example of this is the contactless CP heat maps that were generated in collaboration with OFG. So OFG provided the contactless cathodic protection readings, which were then overlaid onto the 3D Recon models as color-coded heat maps. Importantly, these heat maps were delivered while still offshore, as they were layered directly onto our dense reconstruction. That gave Chevron a clear picture of where the CP was healthy and where further attention was needed. The result was smarter targeting. Instead of re-inspecting every single anode, Chevron only had to send the ROV back to the specific locations that required it, saving vessel time and reducing inspection costs. Now moving on to the V2 development, and as I mentioned, what I'm particularly excited to present is our work towards ROV trajectory control, automated ROV trajectory control. So in V1, we developed our proprietary 3D Recon painter software, which allowed us to plan structured paths before the job, and it calculated line spacing, traverse speed, and offsets based on our field of view and frame rate. So this gave us time and data volume estimates, which already gave the RV pilots a much clearer optimized plan to follow. And with the V2, we're taking that one step further by working towards feeding this direct data directly into the ROV's trajectory control system. The goal is for the vehicle to follow a structured autonomous passes around a structure, ensuring full coverage and consistency every time. We believe we have the data and we have the tools, and we're looking to work with contractors and operators to apply this on live projects. Another major update of V2 is our ability to create a dense reconstruction in real time. We like to call this the ultimate QC tool, as previously we needed a Zupt representative offshore to check the data quality as it was being acquired and spot things like poor lighting, any sort of reflections, high grain, or drift in the ROV distance. Now all of that QC can happen in real time, built into the system itself, as we can see here. So now the ROV pilot can see the dense point cloud, this is happening up here, on their own screen without a Zupt rep on board. That eliminates the need for extra personnel offshore, while also giving the pilot confidence that the flight is capturing everything correctly, which means safer, leaner, and more efficient data. Before we end this presentation, I just want to show you some more examples of the 3D models that we can generate. So this particular data set, it came from a campaign where the operator wanted to build another structure in between existing jumpers. This required a lot of replumbing, so we had to map the entire site, and the result was this fantastic model. Here's another example from a jumper in place metrology we did, which is one of the many positioning tasks 3D Recon can deliver with high accuracy. And finally, here's an example of one of the many hundreds of structures that we have modeled. To finish, I want to touch on where we're heading next. One of our main goals is to work with the operator community to help standardize integrity management data formats. So outputs like point clouds and 3D models integrate seamlessly with platforms like Nexus and Integrity Elements. What we want to do is do this in collaboration with the operators, the survey contractors, and just the wider inspection community as a whole, because the aim is to make the adoption of 3D models as easy and as practical and as beneficial for everyone as possible. Ultimately, 3D Recon V2 is about more than just high quality data. It's about capturing it in a smarter and more efficient and future-proof way that benefits those that use it. Thank you very much. I hope you have learned something, and if you'd like to get in touch about the product, then please do not hesitate to email us.